Okay, so we're looking at another smoothing, this time when you have an even number of terms for the smoothing part. So it looks like we've got a lot of slides, but it's mainly just copying down some notes. Okay, so when we have an even number of terms, the time point around which the terms in the average are being centered is actually not a time point in the original. So when we did it before, when we had 1, 2, 3, 4, and we had a 3-point average, we were putting a value that was associated with t equals 2, which was a real time point. But what's going to happen is once we move to a 4-point average or an even number, we're going to get values that aren't in the original sequence of 1, 2, 3, 4. So copy that and come across and we'll show you what it means. Okay, so we've got a 4-point moving average. So it's the data, say 1, 2, 3, 4. So before, when we had just 1, 2, 3, when I average those numbers, I get 2, which is one of the numbers. But what happens now is when I average those 4 numbers, I get the answer 2.5, and 2.5 isn't one of the numbers in the original series. It falls between 2 and 3. So what we do is we then allocate it to, temporarily we allocate it to a number 2.5, which does not exist. So we're going to come up with a new table. So rather than having 1, 2, 3, 4 and then putting a number with 2, we're going to actually put it with the number 2.5, 3.5, 4.5, etc. So copy that and come across. So let's have a look at this set of data. I think it might have been the same as the original set of data from the first video. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So when we average 1, 2, 3, 4, we get 2.5. So now we've got to average those numbers, 4.32, 791, 607, 1043. We divide by 4 because there's 4 numbers, and we get 7.18. So then the next sequence of numbers would be 2, 3, 4, 5. So when I average those numbers, I get 3.5. So what I want you to do is I want you to average those 4 numbers and then keep going and finish off the rest of the table using that same technique. So I want you to pause the tape and come back when you're ready. Okay, so you should have got 8.91, 9.20, 10.92 and 11.78. Okay, so let's have a look at the next slide. So come across. So generally it's inconvenient to have the average sequence at different times than the original. So we don't normally do it. And so what we do to overcome this is we then take that data set and then we just do a 2-point average of the 4-point average, and this is called centering. Okay, this process is called centering. Okay, so copy that and come across and we'll look at how we use it from that last example. Okay, so we've got these numbers from the previous slide, and so what we're going to do is when we average those 2 numbers, we get 3. And then when we average those 2 numbers, we get 8.04. So what we're going to do is we're going to go back to the original numbers. So obviously we've lost the 1 and 2 data, and we've lost the 7 and 8 data, but that's the price you pay because we're doing a smoothing process. So the bigger the number of terms you're averaging over, then the more data you're going to lose, but the smoother the data is going to be. So what I want you to do is, okay, so the next one will be 3.5 and 4.5 gives you 4, so I want you to average those numbers and then keep going and finish off the rest of the table. And come back when you're ready. Okay, we're back. So you should have got 905, 1006 and 1135. So rather than having 8 numbers, we've now got 4 numbers, but the data is a lot smoother. Okay, so finish off, copy that down if you need to and come across. So when we've got seasonal data and we want to smooth it, okay, we normally do a 4-point moving average, and that's the best way to go forward. Okay, copy that, come across. So looking overall, in selecting the number of terms to be used for the moving average, i.e. the value of k. So far we've used k equals 3 in the first video, and now we use k equals 4. The following points should be considered. Like you can have any value of k, like we also used k equals 2 in that last video, in the last slide as well. But let's have a look at what we should be considering. Okay, so it's always preferable to have an odd number so that you don't have to center the moving average. So if you use an odd number, you'll always stay with the original time numbers, but you'll lose time, but you'll go back to a time that's in the original sequence. And yeah, so this means that the time points will match time points in the original data. So you won't have to do a second average, a second centering. So odd number is best. Okay, so the k moving average when k is large. Okay, so what happens is as the k gets bigger, you over smooth the data, and it reacts only slowly to big changes. So the bigger k is, you get smooth data, but sometimes you over smooth it. And obviously if k is too small, if k is small, then you under smooth it, and so any data changes will almost be the same as the original data, because you're just not smoothing the data enough. So it just depends on how smooth it is, how smooth you need it to be. The bigger k is, the smoother it is, but you lose the data, you lose the changes. So copy that and come across. Okay, the next point I want to make is if there's a seasonal variation. Okay, so seasons don't have to be in 4s, there could be some other seasons as well, but it should be a multiple. So the k value should be a multiple of the number of terms in a seasonal cycle. So if we've got quarterly data, like times of the year, summer, spring, then k should be a multiple of 4. So it could be 4, could be 8, whatever. Okay, copy that, come across. And that's it. So that's the end of that video. Okay, there'll be exercises to do. Bye.